Hello, good people. This is Chapter 9, the part about error types. I figured I'd separate this out from the other information because it was kind of, I don't know, distinctive enough to do so, and I recognized your tolerance to digest long audios of my boring voice. So let's try error types. I think this is only going to be about 4 slides. All right, so hopefully you're somewhat comfortable with this idea of an alpha where we're using this 0.05. So we talked about this before we left, about this idea of, a long time ago somebody came up with this idea that 0.5 was fine. So that we call that our alpha value. So it's basically saying that we're allowing ourselves 95% of the time to be correct in what we say, knowing that 5% of the time we're going to be wrong. So I think, as we mentioned in class before, we had this idea of, well, would I bet my mortgage with a 5 out of 100 opportunities of losing my house? Well, some of you are like, no, I don't want to do that. So if you don't want to do that, then you'd say, all right, well, to hell with the 0.5, I'm going to use 0.1. Give myself a 99 out of 100 chance of being correct and only 1 out of 100 times being wrong. Then some of you would be like, nope, still not good enough. So you could do an 0.001. And as you can see in this second bullet point, I'm going to do an 0.00001. So that's all well and good, but the probability of creating this type of error, which we're going to talk about here at the very bottom, you see this bullet point, we got a type 1 and a type 2 error. If there's 2 different types of errors associated with this, setting your alpha level at an 0.5 or an 0.1 or 0.01. So you see that third bullet point. As you lower the alpha level, it reduces the probability of making a mistake, but it increases the probability of making a different mistake. So this is where this is why we're having this conversation, honestly, is because you can't just get rid of one mistake without increasing the odds of making another mistake. So let's talk about those two types here, type 1 and type 2. All right, so this is a nice graphic of error types. So what do we got going on here? So look at the very far left, decision made on the basis of sample data. So we're either rejecting the null or retaining the null. So again, I'm on the bottom left here. So reject the null, H sub 0. So, all right, let's talk more broadly about this. If you're a researcher and you're trying to cure cancer, you're trying to cure Alzheimer's, whatever, and you want to reject the null. You want to find out that your drug is effective at doing whatever it needs to do. So say the average, again, let's go back to the example about Alzheimer's. So the average symptoms of somebody with Alzheimer's, say, is 10 per week. And you wanted to figure out, and you give them a drug, and you reduce that number to 2 per week. Well, your sample size, your sample average of 2 is significantly different from the sample average of 10. So you say, ooh, I want to reject. They're not the same. Well, a lot of times people are motivated to reject. Why are they motivated to reject? Well, because they want to get published. They want to present at conferences. They want to write books, all this kind of stuff. So there's a lot of social pressures to want to reject. So if you reject the null, again, I'm at the bottom left here, decision made on the basis of sample of your research, reject the null, H sub 0. But if you look at the very top right, true situation, like what's really going on, what's reality going on, if we reject the null, but the null is actually true, we create a type 1 error. So let's just say you do your Alzheimer's research, you get a 2, in reality it's 10, it's in reality it's always 10. In your sample it's 2, but you did something wrong or it's just bad. When 10 is actually the case. 10 is actually the case for your drug is not effective. So what does that mean? You're rejecting when you should have been retaining. So that's bad, because then all of a sudden, if you reject that, then all of a sudden you start saying, ooh, look, I got this drug. I'm going to market this. I'm going to have a whole bunch of people with Alzheimer's take this drug, and it's not effective. So that's type 1 error. And so typically it's an 0.5. So 5 out of 100 times, you're going to make this error because that's what we set it at. So if you do 100 research articles, you do 100 research projects, you're going to reject 5 of them when you shouldn't. That's kind of the sort of the mentality that I need you to have here. But if, let's say, you reject the null, and you look at this true situation across the top right, and the null is false, like they're not equal, and that's correct that they're not equal, then you have that number 3 box, the correct decision. Yay, good job. You just found something. So that's sort of the error that we were talking about initially. So now we got this, but what happens if we want to, decrease the 0.00001 or alpha? Well, we increase the type 2 error. So if you look at the very bottom, the bottom left, decision made on the basis of sample data, your research says I need to keep the null. So let's say, for instance, you're doing this Alzheimer's research and your drug got an average of, say, like 7, but the normal population is 10. What happens if you retain the null? Well, if you retain the null and your drug's not effective, meaning your drug doesn't do anything, you do a number 2. You do a correct decision. You retain the null and the null is true. The problem is what happens if you're 7, your drug is effective, but you retain the null, meaning you said that they were equal, when they're not equal. The equality is false. So that's when you're very bottom right corner here, type 2 error. So what does that mean? It means you should have rejected the null, but you didn't. And what that means is your drug's effective, but now you didn't do anything about it because you said, nope, my drug's not effective. So you can see, I guess, the problem to society is type 2 error is bad because we're missing out on something that could be useful because you're being overly stringent with your alpha level. So again, if you take your alpha level and say, like, I don't ever want to be wrong. I want to be wrong 1 out of 1,000 times. Well, guess what? You're probably going to be more wrong with type 2 error, meaning you're going to actually have something of novel interest in research and adding to humanity, but you've missed out on it because you thought you were being too rigorous. So that's what we're talking about, type 1 versus type 2 error. So it's a weird balancing act. So you don't want to claim that a drug works when it does it, but you also don't want to miss a drug that works when you're being too stringent by saying, no, the drug, I need to do more tests, that kind of stuff. So that's what we're talking about with this two different types of errors. So type 1, reject when you should have retained. Type 2 is when you retain when you should have rejected. So type 1, this is some nomenclature kind of stuff. Type 1 error is called alpha. Type 2 error is called beta. So there is a bit of an inverse relationship here, but apparently it's not a simple subtractive solution. I don't really quite understand it, but it's sort of close. But as your probability in alpha goes down, the probability of beta goes up. So the probability of making an incorrect rejection makes it more likely that you're going to make a incorrect accepting. You might have to rewind that and listen to that one again. So type 2 error, in this very bottom, this last bullet point, type 2 error can be influenced by how different your sample population is compared to the null hypothesis population. And so what does that mean? The likelihood of you retaining when you should be rejecting kind of depends on your sample. So if you kind of have a crap sample, and let's just say you've got a really cool drug. Like, let's say, here's an example. So let's say you're great at making effective drugs, but you're awful at doing research. So what does that mean? That means you create a really good drug, but you're really bad at understanding how to justify your drug works because you're a bad researcher. And so what does that mean? That means you might select a really, really bad sample and give your drug to the bad sample, and the bad sample doesn't really reflect what's really going on out there. So then all of a sudden, whatever you get from that group isn't going to be reflective of all people with Alzheimer's because you got a bad sample. It's a non-representative sample. It's biased sample, whatever. So if that's the case, you're good at making a good drug, but you're bad at showing that it's effective. And so that's what we're talking about with the type 2 error being influenced how your sample, how different your sample population is compared to the null hypothesis population. So if you want further explanation, there's a bit. I'm sure those page numbers aren't correct, but it's somewhere around the error types for chapter 9. So I think that's it. That was a lot longer than I expected. Got any questions, let me know. Out.